Hi, this is Sasha Poquet, and we're starting on the summary video of Module 2 in the course on Social Network Analysis as a part of Learning Analytics series. There's been a lot of materials in Module 2, and some of them were a little bit technical in the tutorial, and some of the extended notes concepts were kind of sticky, social science-y, a little bit complicated probably. But I hope that by the end of the module, one thing that you took away is that what matters in network analysis is the mindset, is the way you think about the questions you ask, metrics you run, and interpretations you draw from them. So in this video, I'm going to remind you of some of the most important, most critical things that you should have taken out of Module 2. So first, let's remind ourselves of the overall process and the critical questions that you should be answering. So you start with wondering what questions to ask and whether the questions you have about your data are network questions. And once you finalize or formulate some kind of inquiry into your data, you have to think, okay, how do I define this network? You need to be precise in defining your nodes, your edges, and the boundary of your network. I cannot iterate how important it is to have a very clear understanding of what nodes you're including in the network, of what your ties mean, and which ties that you are excluding, and if you do have a solid justification as to why some ties are not a part of your network. So for example, in an online forum, one of the problems that I have been tackling with for quite a while is if you have a person A who says something and you have person B replying to that person and you have person C replying to person B. It is very clear that person C is replying to person B, so there is a directed tie. But very often we do not include the tie from person C to person A. Now the question that I struggle with is what is the ground on which we're excluding that tie in the network? Sometimes it matters, sometimes it doesn't. So when you're conducting your own research, when you're constructing your network, you have to be very clear as to why you're excluding certain things and including certain things, because that is ultimately what you're going to measure. The next question in the process is where to collect data and how to construct such a network. Are you going to ask people, or are you going to collect data that's been recorded within some system? And when you're collecting this data, how to make sure that you're ethical about what you're doing? Ultimately, how to make sure that whatever it is you're so passionate and curious about will do no harm to anybody involved. And having gone through these questions, then, only then, you can start wondering what to measure in this to answer the question that I have. Am I interested in the social processes? Am I interested in something else? And once I analyze this network, how am I going to interpret what I find? And to continue, we talked about the typology of questions. So there are three broad categories of questions that you may ask. Why do connections form? So why does person A talk to person B? Is there anything that's similar between the two of them? Is there any benefit that one of them draws from another? What is the reason for that tie formation? What is the reason for the dyad existing in the network? The second type of question is, what is the relationship between node characteristics, node positioning, and outcomes of such position? Does it mean that somebody who is comfortable and comfortable in communication, for instance, as a predisposition to that, does that person going to become very central to the network due to this natural characteristic? And if that person becomes central to the network, what is the outcome of being in the center? Well, for instance, we have shown, some research has shown before, that being central to the network correlates with, for instance, higher sense of belonging into the community where you're central to. The third question to ask is, why is the network structure like this? And what are the affordances of such a structure? In other words, what is the outcome of such a structure? Just to explain a bit here, if you look at the network, for instance, of a team communication, and you then should wonder, Why does this network cluster? Or why is its centralization like that? And then you should ask yourself, well, what is the outcome of this overall whole network structure? Does this network become extremely efficient in problem solving? Or maybe this network is incredibly innovative, comes up with best ideas. Or maybe this network actually seems a bit dysfunctional and average in terms of the team performance, but it's mostly sustainable. And all these outcomes may be of interest to some people and of no interest to others, but that's just the type of question you can ask. So to continue, we also talked about ethics. And there are a lot of things that could be said, so I'm just going to touch upon very few items. When you're conducting your network analysis, ask yourself who benefits from it. If it's a management team that is brought to you on the site, negotiate with them how you're going to protect all the people whose relationships you will be analyzing. Can you guarantee anonymity? And can you ensure that there is a true informed consent and also the opt-out for those who do not want to participate? And now that we're moving more and more into the domain of digital data, and particularly when we look at learning analytics research, what are the privacy expectations that our participants may have? If it is, for instance, a Twitter network, is there a privacy expectation that a person who makes a tweet has? Or should we treat that as public statement? And even if it is a public statement, does that mean that we are entitled to taking this on? All these questions do not have simple answers, but you should be guided ultimately by this concern. What if something goes wrong with what I'm doing? And how do I ensure that I do no harm? From local patterns to social processes, I have put only one slide in the summary video to touch upon this really huge and vast amount of literature that exists about the different social processes that explain how human networks form. And there is no way that I can just condense all of that into this small amount of information and distribute it to you so you know it. So the message here is that there are serious social science constructs, and they have been linked to local patterns within the network. And there are ways of remembering them. And one of the things that a student of social network analysis that you have to keep in mind is that at this point, you should be able to recognize them or simply understand what they mean. And once some of them become more relevant to you, then you go into the literature, you go into the prior research, and you read up, because it's very dense and it's very context specific. So let's just briefly go over the different patterns that are linked to social processes. Networks form, for instance, based on the principle of reciprocity. That is, I scratch your back, you scratch mine. It's a mutual relationship. Another important network process is homophily, which we often refer to as birds of feather flock together. So if you have two nodes who talk to one another in the network, does that mean that there is something similar about them? Another important notion is a notion of transitivity. It is a friend of a friend is my friend. In other words, if I know John and I have a very close relationship with John, it probably means that at some point I'm going to meet John's girlfriend and become friends with her. So this third tie in a triad will emerge eventually if the other two ties are in place. In that sense, the emergence of the third tie and the triplet in the network shows how the relational data is interdependent. Another important concept is that of structural holes or brokerage. So this little image of the guy in the market who's very better off, much better off if she's connected to a lot of different agents who are not necessarily talking to one another, because that puts this person in a position of privilege in terms of the information she receives. Besides the brokerage, another important and very often observed phenomena is that of preferential attachment, or what we call rich-get-richer. In other words, again, I'm using the Twitter example. If you have a Twitter user who is very active and draws a lot of followers, it is highly likely that this person will continue to draw even more followers due to this person's visibility within the network. The final note is this notion of your network versus random graph. This may not have come through to you as the very critical part of the module, but I thought I should include it in the summary video because it gives you an intuitive sense of how you can then eventually move to statistical modeling of networks. Very often when you look at your network, you're just looking at the patterns that exist in one place. But potentially, you can compare that network to a random network. A random network of the same size. And then you can ask yourself, well, how do the patterns of interest to me in my network, how are they different from what would have occurred by chance? And so I'm just going to explain this again in a very simple terms and just to give you a little bit more of the intuition of this concept, because eventually it may become very important in your work. So let's say you have your own network that has these clustering patterns in there, and you're interested in the transitivity because you think that there are some social processes taking place and there is some closure in some parts of the network. But it's only your assumption. You don't really know whether the clustering occurs more than by chance. So what you could do is you can simulate the network of the same size, let's say the same number of edges. And the random graph, assuming of the same size, is not going to look the same because edges are random. There is no pattern as to why an edge exists between the two nodes. So what you can then do is you can simulate this random graph, let's say 1,000 times. And every time you generate a random graph, you're going to look at what is the transitivity, what is the number of triads in this random network. And then you can make a distribution of the frequency of triads in these random graphs and look at the average. And ultimately, your ultimate question here is, how does the frequency of triads in my observed network, how is that different from the average of what I would see in a distribution of random graphs? And so that would allow you to compare these things and draw more meaningful observations from your own network. And that was all for the summary video in Module 2. Thank you, and we'll see you in Module 3.